Welcome to the Enhancing Data Loss Prevention with Integrations module of the Symantec Data Loss Prevention 15.5 Administration course. Awareness, training, and fixing business processes can contribute to a meaningful decrease in the threat that well-meaning insiders pose to the overall security posture of an organization. Risk management for malicious insiders and outsiders, however, can require a combination of additional technologies, people, and processes. Data loss prevention can be the foundation upon which other security and governance solutions can augment risk management of malicious actors. As organizations mature in the adoption of data loss prevention programs, Symantec DLP becomes a repository of intelligence and best practices, underpinning information protection and cybersecurity efforts. Technologies such as Security Information and Event Managers, or SIEM, information classification, Cloud Access Security Brokers, or CASB, User and Entity Behavior Analytics, Digital Right Management Solutions, or DRM, and SSL Visibility Appliances can leverage the best practices, information, and knowledge that Symantec DLP provides. This lesson will explore the Application Program Interfaces, or APIs, and out-of-the-box mechanisms that Symantec DLP provides to facilitate integrations with other Symantec solutions, as well as third-party solutions, such as those previously mentioned. The business objective for this module will be to enhance data loss prevention with external integrations, and it will cover the following topics: Symantec DLP integration mechanisms, Symantec information-centric security, and additional integrations with Symantec enterprise solutions. Symantec DLP integration mechanisms. In this topic, we'll be discussing the mechanisms by which Symantec DLP integrates with other product modules, and also the application program interfaces, or APIs, that allow integration operations to occur. Symantec DLP has been the leader in each edition of Gartner's Magic Quadrant for Enterprise Data Loss Prevention. In the 2017 Magic Quadrant edition, Gartner specifically mentioned Symantec's DLP API support for third-party security technologies, such as content extraction, reporting and FlexResponse for encrypting content, or applying DRM. This topic will explain the most important APIs and other integration options that DLP offers to interact with third-party solutions in the data protection ecosystem. Those integration options can include Cloud Detection Service, a cloud detector that integrates with supported services via a REST API, Content Extraction API, a framework that augments content detection and extraction capabilities, FlexResponse and syslog response rules, which are mechanisms that help organizations prevent data loss in real time, natively as well as through third-party integrations. Incident Data Views is a set of SQL views that allow real-time SQL-based incident reporting, and Reporting and Update API, a web service that provides secure and comprehensive access to incident information. The Symantec DLP detection process has different stages and components where information is treated and analyzed to prevent data loss and perform incident remediation. As shown in this figure, when a detection server receives input content, such as an email, ICAP request, crawled files, or etc., the application layer component, layer 7, splits the message into any available parts: header, subject, body, and attachments. If the message contains an attachment, the content extraction or CE component is invoked to identify the file type and to extract text and subfiles. Extracted content is normalized and passed to the detection component for policy evaluation. If there is a match, an incident is created and saved to disk. If no match is detected, the message is discarded. A separate process sends incidents to the enforce server. As shown in the shaded boxes in this figure, Symantec DLP provides a comprehensive set of APIs to enhance and customize the detection and incident response processes. Symantec DLP Cloud Detection Service consists of a cloud detector residing in the Symantec Cloud that implements a REST endpoint that integrates with supported cloud services through a REST API. The cloud detector receives detection requests from supported services and analyzes received content against your DLP policies. In terms of policies, Cloud Detection Service supports DCM, EDM, IDM, and VML detection rules, and it can return recommended responses to the requesting service or application. Cloud Detection Service currently supports two services for integration: Symantec CloudSOC and Symantec Web Security Service. As shown in this figure, the supported services use REST clients to communicate through JSON detection requests with a REST endpoint. This endpoint is incorporated into the Cloud Detection Service Cloud Detector. For example, the REST client in CloudSOC can send a JSON request to Cloud Detection Service for detection analysis. CloudSOC analyzes traffic against rules specified in the application detection configuration, and if the parameters match, CloudSOC forwards the file contents to the Cloud Detection Service, which stores all DLP policies specific to cloud applications and cloud-based web scanning. If a policy is matched, an incident is created, and the Cloud Detection Service tells CloudSOC which action to take. For more information, please refer to the lesson Preventing Unauthorized Exposure of Confidential Data, previous in this course. This figure demonstrates how user actions, such as transmitting, creating, or manipulating data in a SaaS application or on a website, as well as some application actions, are monitored by the supported services. The supported services send details of these actions to Cloud Detection Service, which analyzes them against DLP policies, captures incidents, and then returns response actions to the REST clients. CloudSOC receives the DLP action and applies it to the identified content, for instance, by notifying the user or by blocking the attempted transmission. Symantec DLP also offers a detection server with a REST API in the form of a virtual appliance, which implements the same REST endpoint as described above. This virtual appliance is well suited for integration with an organization's homegrown on-premises applications, which can then make use of Symantec DLP's robust detection capabilities. Use cases for the Cloud Detection Service and its integration with supported services can include detecting when high-risk users modify files in Office 365 SharePoint, encrypting sensitive documents on OneDrive, adding two-factor authentication to sensitive data files in Box, or blocking high-risk users in a particular geographic location from downloading confidential files from OneDrive. For an overview of Cloud Detection Service architecture and its place in the Symantec DLP suite, please refer to the lesson Overview of Symantec Data Loss Prevention previous in the Symantec DLP Administration course. Symantec DLP ships with a default content extraction plugin for all out-of-the-box supported file types, but it is possible to cover additional advanced use cases using the Content Extraction API. This is a powerful API intended for plugin developers with experience in C or C++ and the file formats that they want to detect. The Content Extraction Host, or CEH, which is typically the detection server, implements the Plugin Manager component, which invokes an interface to load and manage the plugin. In addition, the CEH makes available to the plugin the services provided by the CE API. Plugins invoke these services using the Service Provider Interface, or SPI. The SPI is a set of interfaces that implement the Content Extraction plugin to perform one or more of the following operations: file type identification, text extraction, sub-file extraction, or metadata extraction. This figure presents the SPI operations as used by custom and default plugins, which are managed by the Content Extraction Host and interface with the services provided by the CE API. CE plugins take precedence over the default plugin for the file type or types specified in the XML manifest file. If a custom plugin is configured to analyze files that are supported out of the box, such as Microsoft Word, the custom plugin will override the default content extractor for that file type. In this case, it is important to be sure that the custom plugin provides the same level of functionality as the default plugin for the file type. On the other hand, when a custom plugin performs subfile extraction, extracted subfiles are automatically checked for file type and text extraction. For example, if one of the files extracted is a Microsoft Word file, the extracted file is identified and cracked by the default plugin. CE plugins can be developed for both Linux and Windows-based detection servers. This table shows the requirements based on operating system. The CE API plugin deployment process is as follows. Compile the C or C++ code with the required compiler, create a manifest file, manually copy the required files to each detection server host that will rely on the customized plugin, and then restart the Vontu monitor service. Here is an example of a manifest.xml file. In this example, the image extractor plugin takes TIFF and PDF files and performs a customized subfile extraction operation. Content extraction API plugins can be useful in several business-driven situations. For instance, detecting a recently created new file type. Symantec DLP offers out-of-the-box support for a wide variety of commonly used file types, and additional file types are added with every new release. However, if a business reason demands expedited support for a new or proprietary file type, the customer or a specialized partner can develop a content extraction plugin with this API. Secondly, extracting metadata from an image file. Adding metadata to images and files is a commonly used mechanism to classify and protect information, for instance through watermarks, headers and footers, or custom properties and tags. The Content Extraction API offers a specific interface to identify metadata and support information classification programs. Lastly, using form recognition technology. Symantec DLP form recognition, which is based on the CE API, is a practical application of a content extraction API plugin. The algorithm looks for key points or regions and analyzes the detected images against those previously indexed. This figure here shows an example of a form recognition incident. The image on the left is the template used to detect the filled-in components of the form on the right. Symantec DLP offers a sophisticated detection capability based on content extraction plugins. Digital rights management or DRM solutions can enhance the secure posture of an organization in highly collaborative environments by combining encryption, authentication, and privilege control. However, a malicious insider could potentially use DRM solutions to intentionally obfuscate information. Although this tactic could be detected later by reviewing audit trails and combining other solutions explained in this lesson, real-time protection is the most desirable preventive control. Symantec DLP enables you to detect and prevent unauthorized disclosure of information from Active Directory and files protected by Azure Rights Management Services, RMS, Microsoft's digital rights management technology. By leveraging a special content extraction plugin, it is possible to detect sensitive content in RMS-protected files by securely decrypting them on the fly. RMS detection has specific requirements for the DLP service user's privileges. DLP allows you to choose an existing user at installation time, and it is also possible for customers upgrading from previous versions to change the service using the changeserviceuser.exe command line utility found in the protect/bin folder in both new and upgraded installations. For more information on how to set up your detection server to enable RMS detection, review the knowledge base article linked at the bottom of this slide. Please note that RMS detection is currently supported only on Windows-based detection servers. This includes Network Prevent for email, Cloud Prevent for email, Network Discover and Cloud Storage, Network Monitor, and Network Prevent for web. This figure shows an example of an incident captured when Network Discover scans an RMS-protected file. The window on the right shows the on-the-fly decryption and analysis that the system performs. The FlexResponse Application Programming Interface, or API, provides a flexible platform to perform customized actions during incident remediation after the content extraction and detection processes. It enables Symantec DLP users to protect data by creating customized response rule actions through FlexResponse plugins. Independent developers and vendors can write FlexResponse plugins to perform custom incident remediation using this API and the appropriate programming language. This API has two different platforms, Server FlexResponse and Endpoint FlexResponse. Server FlexResponse plugins run from the Enforce server. The plugin action is initiated either automatically after an incident is created or manually by clicking a custom button for a smart response remediation. Developing Server FlexResponse plugins requires some knowledge of Java programming. Code examples that contain sample plugins for some remediation use cases are available through the Server FlexResponse development kit found in the listed directory, and the Java doc that describes the Java classes for the Server FlexResponse plugins can be found in the adjoining Java doc directory. Full API documentation is provided in the Symantec Data Loss Prevention Server FlexResponse Platform Developers Guide, which can be found on the support.symantec.com website. Symantec provides a set of Server FlexResponse plugins that perform various remediation actions, such as quarantining sensitive data, copying files, and applying encryption. This diagram shows some example network protect actions that organizations can implement by developing a Server FlexResponse plugin. For instance, changing access control lists on files, removing guest access to selected files, for instance. Applying digital rights management, or DRM. For instance, applying digital rights to documents so external parties are restricted in their access to sensitive material. These digital rights may include actions such as do not save or do not print, encrypting files, migrating files to SharePoint, a custom response rule that would move files from shares to a SharePoint repository, and then apply DRM and ACL, performing workflow and automation of incident remediation procedures, and using the Symantec Workflow Business Process Automation workflow. This diagram shows the steps involved in building, deploying, and using a Server FlexResponse plugin. First, create the Server FlexResponse plugin in Java, create the jar file from the Java source files, create a properties text file, copy the jar and properties file to the plugins directory, assign permissions to the protect user, edit the plugins.properties file, restart the Symantec DLP service, and then configure response rules policies and endpoint FlexResponse actions. The Endpoint FlexResponse API provides a flexible platform for incident remediation on endpoint computers. FlexResponse plugins are written in Python and installed using the FlexResponse installation utility for endpoints. The API lets a developer access information that the Enforce server collects about an incident. The API also provides access to the data or file that contains the policy violation. For incident handling purposes, the API reports the status of the Endpoint FlexResponse remediation, and this status is displayed in the incident details in the Enforce Server Administration console. The FlexResponse plugins can leverage existing endpoint credentials and can also receive parameters from the response rule configuration. This figure shows how the Endpoint FlexResponse architecture, components, and interactions work. After an end user violates a policy, the plugin process calls the appropriate methods defined in the Python script and performs custom remediation on the endpoint computer. Then the plugin process reports the result of the remediation to the detection server, and the detection server sends an incident and remediation status to the Enforce server. Endpoint FlexResponse rules are available on the following types of endpoint destinations and protocols: Endpoint Discover, Local Drive Monitoring, Removable Storage Devices, SMTP, and HTTP with HTTPS. The following are use cases that could be implemented through Endpoint FlexResponse plugins: executing shell or batch scripts on specific targets of endpoint computers, applying digital rights management or DRM, applying data classification tags to documents, encrypting files, for instance encrypting a file instead of moving it to another secure location, or redacting data. This diagram outlines the step-by-step process for installing and deploying FlexResponse plugins. First, create and package the Python script, then enable Endpoint FlexResponse on the endpoint detection servers. Deploy the Endpoint FlexResponse utility to all endpoints. Deploy the plugin package. Then configure response rules, policies, and Endpoint FlexResponse actions. Here's an example of configuring a response rule using an Endpoint FlexResponse plugin through the Enforce web interface. Symantec DLP provides the ability to generate Oracle SQL views that can be used for programmatic native SQL access to incident information in the database. Using these views, it is possible to access most fields from the incident snapshot. It is important to mention that these views cannot access encrypted incident information, such as attachments or matches. The incident data access views offer a real-time comprehensive view of DLP incidents. The entity of relation and a data dictionary are available in the Symantec Data Loss Prevention Incident Data Views User's Guide, which is available on request from Symantec Technical Support. This diagram shows a partial view of the logical structure of the Symantec DLP incident database. Detailed documentation of the relationship between incident snapshot information and the incident data views in the database can be found in the Symantec Data Loss Prevention Incident Data Views User's Guide, available on request from Symantec Technical Support. The incident data access views are not automatically available with the default installation of Symantec DLP. These views are created under an additional user that you must create during the installation process, and it is necessary to have access to the DLP database as well as the Oracle SYS account information. This diagram shows the steps to create the incident data access views, and the SQL scripts that perform the installation process are available through Symantec Technical Support. Incident remediation is a key process in any overall risk reduction program. The incident data views are a useful tool for driving down risk by providing real-time comprehensive access to incident information from the Symantec DLP database, reporting across multiple DLP channels, writing SQL queries combining information from network endpoint storage and mobile incidents, and data analysis, third-party data analysis and correlation tools which can consume and analyze incident information feeds, providing key performance indicators and other metrics to decision makers. The Enforce server includes robust reporting and incident workflow features that support incident remediation. In addition, incident information stored in the Symantec DLP database can be made available to third-party reporting, compliance, and remediation systems through the secure Symantec Data Loss Prevention Incident Reporting and Update API. This API lets customers develop applications that retrieve and update incident data stored in the Symantec DLP deployment. The Incident Reporting and Update API is implemented as a web service that resides on the Enforce server. The web service conforms to the Simple Object Access Protocol, or SOAP, 1.1 standard, and it advertises all available operations using a Web Services Description Language, or WSDL document. Web services development frameworks can generate client code automatically based on this WSDL document. One of the most useful features of the API is that it offers match highlighting information in addition to the other encrypted incident information, such as the actual binary attachments that generated the incident. With this option, organizations can write custom solutions for DLP incidents based on their unique requirements. The following operations are available through the API: retrieving incident lists, details, and binaries, batching requests to retrieve incident details, retrieving an incident list to limit the results by date, accessing the list of custom attributes, accessing custom status values, and requesting the retrieval of highlighted matches for one or more incidents. This figure shows an example web services call using the incidentDetail method, along with the corresponding output, which includes incident violations. Here is another example web service call along with the corresponding output for the incident binaries function, which is useful for retrieving any attachments included in an incident. The API also offers methods for updating incident details, which enable organizations to implement rich incident management workflows because critical attributes of the DLP incidents can be modified according to processes being orchestrated via automated or manual external entities. Using the Reporting and Update API, it is possible to update the following attributes: incident severity, incident status, custom attribute values, data ownership, notes and comments for the data structure, remediation status, and remediation location. The Reporting and Update API is available out of the box in the Symantec DLP Enforce platform. Although it is possible to develop SOAP-based web service clients in a variety of programming languages, Symantec currently only offers formal support for Java 1.7 and .NET 3.5 implementations. For authentication, the Incident Reporting and Update API web service authenticates each client request using the HTTP basic authentication scheme. Client applications must supply the credentials of a valid Symantec DLP user in the HTTP authentication header of each request to the web service. Each request must be made over an SSL connection to the Incident Reporting and Update API web service. This figure shows the basic steps to create applications for the Incident Reporting and Update API. First, create a Symantec DLP user and role using the Enforce Administration console. The role needs to have incident reporting, incident update, and sufficient other permissions to run reports and view and update data in these related incidents. Secondly, if the client needs to retrieve a list of incident IDs, a saved incident list report needs to be created in the Enforce Administration console. Next, generate the client code from the Incident Reporting and Update API web service. API code examples can be found at the support.symantec.com website. Lastly, implement the calls to the Incident Reporting and Update API web service, and then troubleshoot the client implementation. The features of the Incident Reporting and Update API offer organizations a wide range of options to customize and tailor advanced and valuable use cases according to business need, service level agreement, or maturity of their incident response strategy. Data loss prevention incidents are, in fact, actionable business events that can be the input for a wide variety of processes, such as the following examples: centralized help desk incident remediation. For customers with sophisticated and centralized incident response workflows, it is possible to triage DLP incidents along with other types of events. Secondly, SIEM integration. SIEMs capable of consuming SOAP web services can use this API to integrate and aggregate DLP information. Thirdly, Symantec Email Quarantine Insight. The integration between SMG and DLP leverages the Incident Reporting and Update API to create closed-loop remediation. DLP and SMG incidents can be managed and resolved in any console. Lastly, searching for specific matching violations. The API allows access to the information that triggers incidents or matches. For instance, organizations can seek specific credit card numbers or other identifiers that are suspected to be stolen. One of the most commonly used out-of-the-box response rule options available in DLP is the log to a syslog server action, which can be used to send information to a central correlation system, or SIEM. The action is available for any type of incident and just requires the following parameters: the hostname or IP address of the syslog server, the syslog server port, the message to be sent to the syslog server, which can contain variables with details of a given incident, and a triage level to apply to the message. Security information and event management, or SIEM devices, are now mandatory components for monitoring and controlling the modern IT services ecosystem. These solutions address the need for compliance and troubleshooting analysis in addition to intelligence that SIEMs provide out of the box. Common integrations with SIEMs are implemented using syslog response rules. However, the incident data access views, as well as the reporting and update API, are also feasible integration mechanisms as well. This diagram shows an example Splunk dashboard, which was created with information directly from Symantec DLP. As a summary, Symantec has been recognized as the vendor providing the most comprehensive sensitive data detection techniques on the market, with advanced functionality that can cover a wide breadth of data loss scenarios. Symantec DLP provides several integration mechanisms and APIs to enhance and mature an information protection program. For instance, Cloud Detection Service, a DLP product that performs detection on content and contextual attributes sent from supported cloud services that integrate via a REST API. Symantec DLP also offers a detection server in the form of a virtual appliance that implements this same REST API. Content Extraction API provides a framework to augment and customize Symantec DLP content extraction capabilities. Plugins can be written in C or C++, and there are 4 operations available: file type identification, extraction of text, extraction of subfiles, and extraction of metadata. The FlexResponse platform technology enables Symantec DLP users to protect data through customized response rule actions. Independent developers and vendors can write FlexResponse plugins to perform custom incident remediation using these APIs and the appropriate programming language. The FlexResponse API enables developers to build plugins that can be used to implement incident responses. There are 2 different platforms in the API: Server FlexResponse, which are written in Java and installed and executed from Enforce. Both automated and smart response rules are supported. Secondly, Endpoint FlexResponse. These plugins are written in Python and must be deployed to the endpoint. With Endpoint FlexResponse plugins, only automated response rules are supported. Symantec DLP exposes unencrypted incident information through the Oracle SQL views called incident data views. These views provide a flexible real-time cross-channel reporting option, and there are 4 main entities that group DLP incidents: mobile, endpoint, network, and discover. Symantec DLP incident information is securely made available through a SOAP 1.1 web service called the Reporting and Update API. Organizations can retrieve incident details, including attachments and matched content. And additionally, the API allows incident remediation to be performed through workflows outside DLP, but still with a closed-loop interface to update incident information such as incident severity, status, remediation status and location, among other attributes. Lastly, Symantec DLP provides an out-of-the-box response rule option to send DLP incidents information to a syslog server. This can be applied to any type of incident, and it is possible to customize the message content as well as the level of alert that is presented to the syslog server. Symantec Information-Centric Security. In this topic, we will be discussing how Symantec DLP improves organizations' risk exposure and data protection programs by integrating with Symantec products and services that form part of the Information-Centric Security Suite. Symantec's Information-Centric Security approach provides advanced data protection by combining data loss prevention, information classification, user and entity behavior analytics, encryption, and user authentication technologies. Data flows across multiple environments, yet remains firmly within the organization's control, viewable only by intended recipients regardless of device location or user's association. Data loss prevention, content-aware policies, or user-driven classification detects sensitive data, whether the data is stored on-premises, on a user's device, or in the cloud. Symantec Information-Centric Encryption protects confidential data with its market-leading encryption schemes. Symantec's recommended information-centric security approach combines solutions across the portfolio addressing data loss prevention, classification, encryption, and user authentication. When combined, these solutions ensure that the appropriate levels of protection and access are applied and enforced. Symantec DLP is central to this approach since it provides general content awareness and visibility into confidential data. Information-centric tagging, or ICT. In this topic, we'll discuss the Symantec ICT product and how it helps solve data classification needs. Symantec Information-Centric Tagging, or ICT, enables an organization to define and apply a consistent data classification and labeling policy. Data classification consists of multiple tags, each tag containing 3 levels of metadata, referred to as company, scope, and level, that identify the tagged content's place in the classification hierarchy. Users apply the tags and watermarks to files and emails as they work. Here are some of the use cases supported by Symantec ICT. Data classification and labeling enables organizations to classify newly created content, existing files, and emails in a policy-driven or user-driven manner. Role-based taxonomies and policy. Using ICT's policy engine, organizations can set up different classification taxonomies and policies to be applied to designated users. Dynamic watermarking and tagging lets organizations automatically tag and watermark unstructured data, including emails, documents, and images, according to enterprise policy. Enterprise-ready architecture provides a highly scalable architecture with a centralized management that integrates with Symantec DLP, Symantec Information-Centric Encryption, and Active Directory. In addition, comprehensive audit trails provide visibility into user and administrator actions, facilitating regulatory compliance and forensic mandates. Additionally, ICT also tracks user activity with regard to classification tags and their use. For example, ICT might record the actions of a user who changes the tag on a confidential file from confidential to public to evade scrutiny, and then transmit the document outside of the company's network. Plugins for native Microsoft Office applications or a Windows Explorer context menu, as well as the mail clients in iOS, Android, and BlackBerry, provide users with a seamless interface allowing them to tag documents as they are created and updated, and as emails are sent. When a Symantec DLP administrator adds these tags and watermarks to detection rules, DLP can read them and take defined response actions. This figure shown here shows an overview of the ICT user experience. When ICT is deployed locally, users are prompted to classify their documents before they can send or save. Optionally, administrators can also include links to guides to help users classify their content correctly. The integration between DLP and ICT supports several unique features. It lets all DLP products detect ICT tags in analyzed content, and it also lets Endpoint Discover enforce auto-application of ICT tags during an Endpoint Discover scan. Meanwhile, the integration lets ICT send content to DLP for analysis against DLP policies, instead of against native ICT policies only, to detect confidential content and to specify ICT tags. This figure shows the architecture for the DLP and ICT integration. Enforce and the ICT console have been configured to communicate with each other. Enforce imports specified taxonomies from ICT and can sync or re-import them on a regular schedule. The DLP endpoint server manages the DLP agent running on the endpoint computer, along with the ICT agent, which applies all the tags. The use case of ICT using DLP policies to detect and tag confidential files highlights some of the architectural details. When an end user saves a file, the ICT agent detects the action and tells the DLP agent to analyze file content against your DLP policies. If the DLP agent detects a policy violation, it tells the ICT agent to apply the tag specified in the DLP response rule. Note that for this use case, a Symantec DLP Endpoint Prevent license is required. CloudSOC. In this topic, we will discuss Symantec CloudSOC, a Cloud Access Security Broker or CASB that integrates with DLP to ensure that files matching policy are appropriately handled when they are used in cloud applications. Robust web security that can deter cyber attacks and stop malware intrusions has become established as a requirement in today's threat landscape. Adoption of BYOD and the frequent use of often non-sanctioned cloud applications has pushed the placement of these controls to hybrid or fully cloud environments. The market for Cloud Access Security Brokers, or CASB, has emerged as a strategy to provide a distributed policy enforcement platform while keeping the flexibility demanded in today's web applications. Besides typical URL filtering, malware protection, and compliance rules, CASBs are expected to offer additional services, such as identity management services, profiling, and logging and alerting. Symantec CloudSOC is a comprehensive CASB solution that leverages multiple control points, including APIs and inline gateway and security logs, to continuously monitor and control an organization's use of cloud apps and the Internet to ensure that Internet transactions are compliant and malware-free. Mature data loss prevention remains an important customer requirement. and as much as possible, organizations are seeking to consolidate investments and apply existing incident remediation processes and policies to their cloud initiatives. Symantec helps customers meet these requirements by letting them integrate Symantec DLP with Symantec CloudSOC using the DLP Cloud Detection Service. As shown in this figure, the integration between DLP and CloudSOC enables a single console to extend DLP policies to data transmitted to or residing in cloud applications, while leveraging CloudSOC's real-time remediation, such as blocking. At the bottom left of this figure, you can see the Enforce server, which is connected to the DLP Cloud Detection Service Cloud Detector, hosted in the Symantec Cloud. When a user interacts with a cloud app, for example attempting to upload data, CloudSOC monitors the interaction and forwards the content and any contextual attributes to the Cloud Detection Service for analysis against DLP policies. In case of a violation, the Cloud Detector captures the incident and returns a verdict to CloudSOC, which then takes the appropriate action, for instance, blocking the attempted upload. Information-Centric Encryption, or ICE. In this topic, we'll discuss how Symantec DLP integrates with ICE to ensure that sensitive files are protected with encryption. Information-Centric Encryption, or ICE, protects data through the use of encryption along with permission sets that control how users or devices can use that data, for instance, reading, editing, printing, or forwarding it. This kind of protection is useful, for instance, when an organization needs to share sensitive documents with partners, but wants to prevent the documents from being forwarded to competitors or potentially malicious actors. When integrated with Symantec Data Loss Prevention, ICE can apply encryption and permission sets automatically and in a content-aware manner. Integration with CloudSOC extends that protection to the cloud. Authorized users have or can download the ICE utility, which lets them access ICE encrypted data in accordance with ICE permissions. The integration between DLP and ICE supports the following use cases. First, Endpoint Prevent can encrypt and protect confidential files copied to removable storage, or for Windows endpoints, uploaded by browser, meaning HTTP or HTTPS on Firefox, Chrome, IE, and Edge. Second, Network Protect can encrypt and protect files discovered on file servers and SharePoint servers. Third, Cloud Detection Service integrated with CloudSOC can encrypt and protect files uploaded to Box or residing in OneDrive. Lastly, Cloud Service for Email can encrypt and protect files emailed using Office 365 Exchange or Gmail G Suite. As shown in this figure, ICE is not physically networked to any part of the DLP infrastructure. Both DLP and CloudSOC can be configured to call ICE when they detect confidential data on supported vectors and when policy requires it. ICE then passes the encryption keys to the relevant server, service, or endpoint to encrypt, and for endpoints to decrypt the file. Information-Centric Analysis. In this topic, we'll describe how ICA, powered by Bay Dynamics, pulls incident information from DLP and other sources to improve remediation, investigation, and provide user entity behavior analytics. In recent years, the developments in big data architecture and algorithms have helped organizations reach the next level of visibility across their environments, especially around user behavior and information flows. Although security information and event management systems have powerful rules and signatures to process information, it can be challenging for some solutions without a considerable amount of expensive human effort to create scenarios with the number of variables that are involved in current business operations. In bringing together the information-centric security package, Symantec has united a number of solutions that work in concert to protect customer information, wherever and however it travels. Information-Centric Analytics, or ICA, powered by Bay Dynamics, aggregates events from several of these solutions and then correlates those events with data from other sources in your network to reveal risky behavior by users in your organization. ICA helps unify and prioritize incidents, manage workflows, and facilitate remediation, with much of this functionality available out of the box. In doing so, it lets you simplify DLP remediation, identify malicious insiders and outsiders, and analyze cyber breaches. Here's an example use case for using information-centric analytics. An employee, Tom, connects with a tablet to the corporate network through a VPN using an overseas gateway. He logs onto the CRM solution and downloads product materials, roadmap information, and customer contact data. Some of the factors that may need to be considered by any user and entity behavior analytics system are: has Tom used this VPN gateway before? Are these Tom's normal working hours? Who's the internet service provider? Is this a device that's corporate owned, or is this Tom's device, or somebody else's? Who has used this asset before, and is this asset compliant with security policies? Are Tom's peers accessing the same information? A scenario like this may be either a completely normal business process or the preamble to a risky situation that can go unnoticed among the millions of events that an SIEM processes every day. By using data science and machine learning, UEBA solutions are able to provide dynamic scenarios and thus enable organizations to create baselines and detect anomalies or outliers in user behavior and data usage. That knowledge can increase the organization's ability to detect flight risk users and even predict and stop data loss and other risks in the future. Such technologies can address business concerns such as the following. How would this situation be impacted had Tom just received a discouraging performance evaluation, or if he were a contractor? How does Tom's risk score compare with other users from the same business unit? How does Tom's risk compare with baseline behavior in the industry? Has Tom generated any DLP incidents, including any that have already been resolved? As shown in this figure, ICA is a software analytics platform that provides an integrated, contextually enriched view of cyber risks within your enterprise. It ingests, correlates, and distills large amounts of security event data from a range of products, including all data exfiltration channels, such as data telemetry, user access, identity telemetry, corporate asset data, and alerts from other security systems, threat telemetry. Symantec DLP provides detailed information about violations of corporate data protection policy, including the responsible source. Other data sources supported for ICA include Symantec CloudSOC, Symantec Information-Centric Encryption, and Symantec Information-Centric Tagging. Microsoft Active Directory provides identity data, while other business applications such as HR systems provide further insight into influencing factors and identifying risk, such as leaves of absence, disciplinary incidents, and so on. The risk analysis produced by Symantec ICA can compile data from various data sources, including Symantec DLP, and then aggregate this data in formats that facilitate investigation and remediation, an example of which can be seen in this figure here. Validation and ID Protection Service, or VIP. In this section, we'll briefly explain what this product does and how the VIP service fits into the broader information-centric security product bundle. The purpose of the information-centric security product set centers on ensuring that information is safe, secure, and accessible to the right people, wherever it resides. As that residency may also include cloud applications, it is sensible to ensure that accounts used to access such data cannot be used by unauthorized third parties due to weak or recycled passwords. This can be achieved when VIP, Validation and ID Protection Service, is used in combination with CloudSOC. CloudSOC can enforce policies authorizing access to an application, and further, ensure that specific actions taken within those applications require two-factor authentication. This means that confidential data remains in approved locations and is accessed only by authorized users. The second way VIP enhances the information-centric security product set is by providing two-factor authentication functionality for encrypted files. An example use case for this functionality is if someone attempts to access an ICE encrypted file residing on removable storage from an unknown computer, that person will be prompted to authenticate before accessing the file. In summary, to reduce threats from malicious outsider and insider threats, it can be effective to use Symantec DLP in concert with other Symantec solutions in the information-centric security product set. Organizations can leverage their current investments, increase their resilience to cyber threats, and improve their risk posture. In this topic, you learn that the value proposition of the integration between advanced content detection, information classification, encryption and permission sets, event correlation and analysis, and user and entity behavior analytics. Additional integrations with Symantec Enterprise Solutions. In this topic, we'll discuss Symantec's enterprise security long-term strategy and how DLP integrates and leverages other Symantec products and services. Symantec's mission continues to be about keeping organizations safe from ever-evolving digital threats so that they can feel confident focusing on their business without the distractions of security worries. This topic provides an overview of Symantec's position as the largest cybersecurity company in the world, with a strategy both broad and deep that takes full advantage of our differentiators, our presence across key control points, our unrivaled scale of telemetry, and our rich set of security technologies. Symantec DLP is a very important component of Symantec's strategy because DLP analyzes and protects information while in transit, in use, at rest, in the cloud, or on premises, providing an unrivaled amount of business interactions and knowledge that can augment and improve other Symantec solutions. Gartner noted this factor in the 2016 MQ by remarking that Symantec's strategy demonstrates a strong understanding of the technology, socioeconomic, security, and jurisdictional trends that will shape its offerings going forward. The previous topic highlighted Symantec DLP within the context of the Symantec Information-Centric Security product set. This topic will show several examples of how DLP integrates with Symantec's broader portfolio of solutions and services to protect organizations' most valuable information assets. Symantec's Control Compliance Suite, or CCS, is a solution that automates key IT risk and compliance management tasks. CCS ensures the coverage of external mandates through written policy creation, dissemination, acceptance logs, and exception management. With CCS, organizations can demonstrate compliance to both external regulatory mandates and internal policies, linking the written policies to specific technical and procedural standards, and assessing the policies using a highly scalable agentless or agent-based tool. CCS scores assessment results against specified risk criteria. CCS also supports automated assessment of the system security configuration, permissions, patches, and vulnerabilities. CCS also supports the assessment of procedural controls and entitlement review through a manual attestation process. CCS External Data Integration, or EDI, lets organizations seamlessly assimilate data from an application that is external to CCS into dashboards and reports. CCS has a pre-configured option to import information from Symantec DLP incidents through the Reporting and Update API. CCS consumes the imported incidents data to generate dynamic dashboard panels based on key performance indicators relevant for DLP, such as any of the following: responses to DLP incidents, top 10 DLP incidents by protocol, or top 10 DLP incidents by user. CCS offers a pre-shipped assessment procedure called Symantec Data Loss Prevention Policy Violation. The procedure evaluates whether any incident fails against an asset. If so, then that asset is marked as failed for the assessment procedure. CCS also generates policy compliance reports. As part of the Symantec Data Loss Prevention integration, CCS displays the following predefined policy reports for compliance: comparison of control statement mapping, policy compliant by assets, policy control statements mapping, and policy results by controls. Finally, risk score for the DLP incidents can be calculated using an aggregation from assessment procedures and the severity of the DLP incidents. Host integrity from Symantec Endpoint Protection, or SEP, ensures that client computers are protected and compliant with your defined security policies. Host integrity policies can be used to define, enforce, and restore the security of endpoints to secure enterprise networks and data. Using FlexResponse technology, Symantec DLP, in conjunction with SEP, can dynamically apply strict endpoint protection policies as a result of DLP incidents. The client computers run the host integrity check, which compares each computer's configuration with the requirements contained in the host integrity policy. The host integrity policy checks for the existence of antivirus software, patches, hotfixes, and other security requirements. For instance, the policy may check whether the latest patches have been applied to the operating system. Based on the results of the host integrity checks, whether pass or fail, SEP can enforce additional actions, such as placing endpoints in quarantine for remediation, while applying restrictive firewall, application control, or device management policies. If the Symantec DLP agent detects data loss incidents, an Endpoint FlexResponse rule can trigger an action, for instance by creating or modifying a value in the Windows registry, that in coordination with host integrity will strengthen and lock down the culprit endpoint for triage. The Symantec Endpoint Encryption, or SEE, FlexResponse plugin integrates the detection and enforcement capabilities of Symantec DLP with the encryption features of Symantec Endpoint Encryption, removable media encryption. With this integration, any sensitive files that are written to removable media can be encrypted automatically. When a file is written to a removable media device, Symantec DLP evaluates its content against policies. And if the file is confidential, Symantec DLP executes the SEE FlexResponse plugin as specified in response rules. The FlexResponse plugin then communicates with SEE removable media encryption to encrypt the file. Based on the availability of default credentials, SEE either prompts for a credential or encrypts the file automatically. Email Quarantine Connect is the integration between Symantec Messaging Gateway, or SMG, and Symantec DLP for the detection and remediation of sensitive messages, enabling organizations to remediate the resulting incidents on either platform. The integration relies on the Symantec DLP reporting and update API. Typically, the integration is intended for a workflow where Symantec DLP applies response rules to analyzed email messages and sends suspect messages to SMG, where they are quarantined pending further remediation. Using the Symantec DLP Enforce Server Administration Console, users can initiate remediation actions such as releasing the message from quarantine, deleting the message, encrypting the message, or performing other actions. The users can also initiate those remediation actions from the SMG Control Center. Regardless of the platform where the remediation is performed, the incident details are updated on both platforms with information about the remediation. Symantec DLP Cloud Service for Email is a great example of the integrations that compose the next generation of Symantec solutions. DLP largely concerns itself with making sure that confidential information does not leave the organization. However, when email administrators think about the flow of their email traffic, they are equally concerned about ensuring that nothing risky gets in. This is why the integration of DLP Cloud Service for Email with Email Security.cloud is such a powerful combination of Symantec services. It provides the essential layer of security that organizations need to protect their email services. Symantec Email Security.cloud protects organizations against targeted attacks, spear phishing, advanced malware, spam, and bulk mail. Its combined technology stack prevents email-borne threats and unwanted messages from reaching user mailboxes, while policy-based encryption, using Symantec's Policy-Based Encryption Essentials, can ensure that sensitive email exchanges between customer and clients remains private. Email Security.cloud's proprietary heuristic technology, Skeptic, is a rules-based detection engine that can identify malicious code that other products may miss. Skeptic examines multiple attributes of an email and its attachments, looking for any anomalies or unusual characteristics. It is also coded to trigger on previously unseen behaviors that are unlikely to be benign. Since the service is cloud-based, it is scaled to run quickly while also retaining a useful record of known characteristics. The infrastructure is certified against international security standards such as ISO 27001, SAS Type 2, and so on. Symantec.cloud sees threats as they emerge in real time. Anything learned means new heuristics rolled out to the infrastructure in real time. This means that all Symantec.cloud customers get the benefit of Symantec's knowledge as soon as we make updates, and not when it's convenient to install a patch. Customers with Email Security.cloud Protect can also take out ATP Email, which adds further controls and protections to inbound email traffic, and integrates with a broader ATP portfolio. With this product combination, customers are assured that only approved email traffic is in motion, regardless of the direction of traffic. As organizations adopt more cloud applications, they need a robust cloud-based web security solution that maintains security and compliance without needing to route all traffic through an on-premises web proxy. Symantec Web Security Service, or WSS, is a cloud-based subscription service that provides enterprise-class web security for endpoint computers and devices connecting to the web. WSS protects endpoint computers and devices from threats and malware, and controls web usage through URL filtering and categorization, and also supports various authentication methods, including integration with Active Directory, to let you tailor your web access policies to specific users and groups of users. WSS supports universal connectivity by covering endpoints and devices whether they connect from corporate headquarters, remote offices, or with the use of a WSS agent or app from outside your corporate network. This figure depicts a diagram of how headquarters-based regional and remote users can access cloud applications through Symantec WSS. Symantec WSS integrates with Symantec DLP through the DLP Cloud Detection Service to enhance web security with mature DLP protection. When WSS is integrated with Symantec DLP, WSS sends content to a Symantec DLP Cloud Detection Service cloud detector, hosted in the Symantec Cloud, for analysis against your DLP policies. Cloud Detection Service captures any incidents and returns a verdict to WSS, which can then take appropriate action, for instance, blocking an attempted upload of confidential data. The most prevalent data obfuscation technique today is encryption, and the majority of cloud applications and general internet traffic now use SSL or TLS by default, which poses a challenge to organizations that require visibility into traffic traversing and leaving their networks. In recent years, there has been an important evolution in the SSL visibility and decryption market. An SSL visibility appliance is a dedicated network appliance designed to decrypt SSL traffic and provide a clear text stream of the session using a network tap port. Symantec DLP Network Monitor can receive and monitor the clear text packets from SSL visibility appliances for all protocols that Network Monitor currently supports, such as SMTP over TLS, FTPS, and HTTPS. The integration between Network Monitor and SSL visibility appliances is passive inline. The appliance serves as a bump-in-the-wire device between a user's managed enterprise computer and the website that the user is accessing. Symantec has certified Network Monitor for integration with the Symantec SSL Visibility Appliance, as well as with the Palo Alto Network's next-generation firewall SSL TLS decryption feature, to enable monitoring of SSL traffic passing out of the corporate network. This figure shows a diagram of the Symantec SSL Visibility Appliance decrypting traffic from a user and sending a copy of that decrypted traffic to Network Monitor for analysis against DLP policies. For additional details on this integration, please see the guide Using the Blue Coat SSL Visibility Appliance with Symantec Data Loss Prevention Network Monitor, available on the support.symantec.com website. Symantec's Cloud Workload Protection, or CWP for storage, helps ensure the integrity of data stored in Amazon S3 buckets, while preventing the spread of malware to other applications, storage, and users. Symantec's suite of SEP anti-malware technologies, including advanced machine learning and reputation analysis, helps to identify and remediate the latest threats to keep cloud storage clean. CWP for storage also protects against data breaches by discovering and alerting when S3 buckets are misconfigured or exposed to the public internet. The CWP for storage with DLP integration applies Symantec DLP policy to objects in S3 buckets so that you can identify and remediate at-risk confidential data. Confidential information can be identified with AWS tags, enabling additional capabilities such as customized automated remediation. Near real-time and scheduled anti-malware and DLP scans occur entirely inside the customer's tenant, ensuring protection of confidential data during assessment. This figure shows some details of how CWP for storage with DLP protects data residing in the Amazon cloud. First, CWP will connect to the AWS tenant. The admin can set policies and scan schedules, and then when the user uploads objects to Amazon's S3 bucket, file analysis will occur. When a file that violates policy is found, an SNS alert is sent to the controller, and the DLP REST API virtual appliance analyzes the file and sends an incident to enforce. Afterward, the scan results will appear in the dashboard. This lesson has explained how Symantec DLP provides a platform for organizations to create a sustainable data loss prevention enterprise architecture through several integration mechanisms, or APIs, that Symantec DLP provides. Analysts have recognized Symantec DLP for its comprehensive sensitive data detection and advanced incident response functionality that can cover a wide breadth of data loss scenarios. Based on the underlying detection process, we reviewed the Cloud Detection Service REST API, Content Extraction API, Incident Reporting and Update API, Symantec DLP response rules, and the incident data views. We have also discussed that although the current threat environment is constantly evolving, data loss and other advanced threats can be prevented, but it requires multiple solutions that work together to solve the problem. Symantec provides leading solutions to address many of these challenges. Through use cases and examples, this lesson has covered several integrations with other powerful and mature Symantec solutions. Thank you for joining us. This concludes the Enhancing Data Loss Prevention with Integrations module of the Symantec Data Loss Prevention 15.5 Administration course.